All right. Hello, everyone. I guess we'll get started right now. So I'm going to be working through this repository if you want to follow along, but everything will be on screen pretty clearly. Is this big enough? Yeah, it looks fine. Okay. So the subject of today's talk is basically we're going to go through how Nexus Development, which is our development shop that specializes in Ethereum smart contract development, how we design systems of contracts and how we just make sure that they're future-proof and that we can upgrade them. And then when we do these upgrades, how do we structure it so that when we're manipulating chain data, everything is safe, basically. And then, so I'm going to basically walk through the creation of a token system, which this is, I guess, everyone's first smart contract that they usually write is a token contract that implements the token standard. Now I'm going to actually, what I'll be doing is going through the commit history as if this is a live coding thing, but actually I wrote this over the past like 3 hours. So let's see. Yeah, what's going on? All right, so what you see here is basically I created a new directory. I did git init, and then I did dapple init. Now I should take a second. During this talk, I'm going to be referring to a few command line tools you might not have, but in the README that's on the on this full git URL, dev/demo. There you'll see like all the install instructions for various tools that I'll be using. But anyway, dapple is our build tool for Solidity contract systems. The initial repository is the result of doing dapple init, except it's missing the contracts directory, which is visible here. And let's see. Let me actually check out. Sorry, I don't have the commit history in front of me directly, so I'm going to check out Smolder. Let's do this. All right, so it's just empty. Oh, I see what's going on. Sorry about that. Okay, so if you do dapple init, you'll be given a contracts directory, a build directory, and a dap file. A dap file is kind of like a package.json file for your Solidity project. It's basically a name, version, dependent projects, and this layout here. The contracts is where your Solidity sources live. The build directory is where your build artifacts are going to go. Okay. So another thing that we did is we cloned. We did this command gits. Let me clear the screen. Git sub module add. Then we added a dependency, which is here, ERC20, and added it into our dapple packages directory. You'll see this is ERC20 is the token standard definition contract, right? So this is what we're going to be implementing. And this is a token standard that the Ethereum community has established in the last couple months, and it's also very simple to implement. There is a full implementation here in base. But what we're going to be doing is we're going to be taking this base contract, making an upgradable version of it, and then doing an update to it. Deploying the first version, then realizing that we want a behavior change and updating the contract on the fly so that it implements the new behavior. Before we get to there, it started basically by creating a test, a demo token, which extends the base contract, and a test for it. Now I'm going to talk through one of these at a time. Dapple, I think you can't see the top of my screen there. Dapple injects a virtual package, which has this test-based contract, which you can inherit from. Now, what this what the point of this system is that you can write your you're in the same language as you're writing contracts in. And this has trade-offs. It's kind of inconvenient because you can't tell all test case. You can't like test all possible cases, but it does make for a lot less context switching. And basically the insight is that your contracts are going to be called by other contracts more than by humans, hopefully. And so this testing it in that environment can, it's just nicer. Let me check the chat real quick. If looks like there's no questions. All right. So the way this is run is with dapple test. If you don't have the local Solidity compiler installed, then it'll still work, but it will be very slow because it's going to be compiling in the JavaScript VM. That should also be covered in the README setup instructions. So this shows two types of tests: a passing test and a test that is supposed to throw an exception. Right now, that's just detected by the name. If it's prefixed with test fail, that means it detects an exception. So the test contract has the same pattern as unit tests in most other languages. So there's a setup function, which is run. There's a new object instantiated. The setup function is run, and then just one of these tests is run, and then that happens once for each test case. So you get a fresh context. So in this case, we are just extending. Let me open the token contract again. We've extended the base token contract on which this balances. Let's focus down here at first. This balances mapping is just exactly what it sounds like, and we added a function that basically sets the balance and overrides other. It doesn't have any other logic basically, and it's protected by this admin only modifier, as is the function which updates the admin itself. What this does is, if the sender is not the admin, you throw an exception, and the admin is initialized on construction of this demo token. So this is pretty much like a general purpose. Like if you're any sort of application where there's an admin that can have backdoor access, then this is all you need. Basically, you don't need any more on-chain logic than what we have here. Now let's see. Right, so we have a failing case when a non-admin tries to set the balance, and this is done via proxy tester contract, which is initialized here. Now this is a little, this will take a while to explain, so maybe it's better to just refer you to documentation. If you go to our Nexus Dev website, you'll see, which is nexusdev.us. If you go there, you'll see a bunch of different repositories. Dapple contains documentation that explains how all this works. So there, if you want to dig into the details of how exactly we test this proxy call, you can look there. But basically, this test confirms that this admin feature works. Okay, now let's see what I did next in our history. Right, so the next update we're going to make, it's a rewrite. We decided, okay, instead of having an admin, instead of having the old admin system where each contract would have to have its own local reference to one address that it trusts as its admin, instead we're going to invent the concept of a component. Now, a component is also a base contract. It doesn't have any external functions at all, which actually means it has no code if you try to compile it. Instead of an admin, we're going to have something called a manager. And a manager is just something that provides this isRoot function. So basically, what this contract does is it lets us have a set of admins that the admins themselves can manipulate. But then every single contract in the system only has to have a reference to one sort of access control database. And this is a simplified version of something that we actually have in production live now on Ethereum. And this is sort of this admin contract is in that system is itself protected by a multi-sig. But here it's very straightforward. It's just a set of super admins that can do anything to things that are protected by this auth modifier. So going back to the token, before our set balance was protected by a custom local admin protection function, and now it does auth, which is a lookup to this component manager. This syntax is basically initializing the super classes, right? So a demo token is both a token base, and it's one of these components that means it links against this admin like access database, and then it uses that to look up who can set the balance. Okay. So this is pretty good. We have a pretty high utility token contract already. But let's jump ahead to what if we wanted to make this system updatable. Right now, suppose that we wanted to add an extra layer of behavior. What we could do is pretty limited because of the fact that this contract still exposes all the like the transfer and the transfer from and the allowance function, which are the standard token contract functions. So instead, this is probably the biggest jump that we're going to have to do in the whole talk. When you look at the chat, can you explain what a base? Oh, can you turn your terminal bell off? Yes, I can. I can do that. Could you explain what a base contract is? Yes, I'll explain that. A base contract is a contract with no. Sorry, I'm looking at my preferences. Let me do this one thing at a time. I'll just turn my volume down. Actually, I don't need my volume, and then you won't hear the bells. Okay. A base contract is a contract that only has internal functions or modifiers. So again, this component, this constructor is called when it's initialized, but there's no other entry points, right? This modifier auth isn't actually compiled unless it's used by something else, by a different function. And same with if you had an internal function, that would also not be compiled in unless you were using it. So this is something, a base contract is something that's only useful to inherit from. Okay, so this is the biggest jump in the whole in this whole talk, which is that we split the token contract into three different token contracts. So where the old contract was, we have something called front end. Now, actually, let me step back and give you some motivation for this. Suppose we had the regular token contract, but then we said, hey, we're going to separate the data into a second contract. So anytime that it would writes to its own storage, for example, what we had that where we saw it set the balances, instead we can call out to a dumb data contract and keep our balances there. And then this lets us preserve our data if we migrate the behavior. But then on the other side, there's the problem that other people are hard coding your address into their contracts. There's no good universal registry or lookup scheme, and there really can't be. So if you want to make it so that you can preserve your data during logic updates and preserve your entry points from dependent systems, then you need three contracts. So we have something called a front end, which implements the same interface as the actual token. So you hand this to someone and say, hey, this is a token contract, right? And you know, they don't have to think about it further. They can just think that it all implements all the business logic right there. We also added, that we made use of the component here to keep track of the controller. This is actually should have been deleted in this version, and I just didn't have the time at that commit. So the important thing here is it has emit functions for all the events it's supposed to emit, which are protected, and it has for all the contracts that depend on the sender, it has to forward the sender also, because you can't preserve that across function calls. And there's a better way to do this more recently using libraries and delegate call, but we are not going to cover that here. This is simpler. So then the heavy lifting then lives in the controller, which basically has all the same business logic as the dumb transfer contract, but you can see that it's anytime that it writes state or reads the state, it's delegating it to this database contract. And likewise, it's emitting events on the front end. And then on the very bottom there, you have the data store contract, which has the DOM getters and setters. All right, so in this case, this lets us basically keep it updatable. So first I'm going to show you how this is even set up. So you have your manager, which is both the environment lookup with the names to addresses mapping and the isRoot lookup. It's like a simplified Doug-like, if you know about that pattern. And it's a simplified version of what we have available as a public library called Dapsys for making these kind of systems. And then, yeah, so we construct the new version. We construct the front end, the controller, the data store. They're all hooked up to the manager. Give them all root because they need to call each other. You can already see how that's not totally general, and you might want more fine-grained permissions, and we have that available as a library, but this is like a very basic way to do it. And then, yeah, you set them up in the environments. You refresh the environments on the contracts that depend on these environment variables, just so they can pull them into storage locally, and it's a little more efficient. Set up our tester proxy. And then basically, yeah, we added one test. I added one test during this time to basically, yeah, confirm that the token system still works the same way. That if this transfer function worked, then it probably works. We do have, I actually cheated a little bit. I didn't actually write this whole thing in 3 hours. Like I said at the start, it's, I copy pasted the data store controller front end version of the token from a different repo that we have. So that's why I didn't actually add more tests either. Yeah, I know, because I know it works. Anyway, so the interesting part is, what does it look like when we want to update it? So first, I'm going to show you, first let me just show you this in practice. So yeah, we have this in the test context. We set this system up in the setup function, but then like, okay, I actually want to set it up on the real network. So we have a concept of an installer. An installer is, well, I guess I call it a factory here, but an installer is something like a factory, but it has to do a lot of setup logic. So here I copied the logic from the setup function. The important thing here is at the end, this is an interesting thing. It removes its own root permissions from the system that it just built, and it instead gives it to the person that calls this. So if I call new demo system, the result is the same as if I had, in terms of permissions, the result is the same as if I had constructed a new contract and that I had become the automatic, or then I had specified the manager there. So this, yeah, the result of this is that if I call it, if I deploy this contract, and then anyone can call it and get an entire upgradable token system. So now we get to the most interesting part. Sorry, I'm switching to the chat real quick. Someone asked, any gas requirement concerns? Actually, this is mostly motivated by gas requirement concerns, the separation. Well, yeah, in this repo, there's not an example of it, a good example of it, but in Dapsys, in the system contract repo, you can see a few examples where, like, yeah, some things have to be split up across multiple setup steps. I'm going to talk about that a little bit more at the end, about off-chain versus on-chain, like, setup sequences. First, I want to get to, oh yeah, but just to show that it works in this version, in the setup, I just replaced that whole setup logic with deploy a new factory and then get a new demo system, and then I pulled these variables out of the environment of the manager. Okay, so now I'm going to check out this version, which is okay. So I decided that. You know, this behavior is not good. I want to whitelist recipients in my token system. Like right now, the old business logic, it did not, it just allowed anyone to transfer tokens, but I want to replace my controller with one where only whitelisted people are allowed to receive tokens. So our refresh environment, first I refresh this superclasses environment, which had the front end and the database, but then I whitelist, yeah, I construct and add this, sorry, I pull the whitelist from the environment on a refresh environment. And then in the transfer and transfer from functions, I just add an extra check before the superclass's business logic, which says if you're not allowed, then you can't transfer. And allowed is just a very dumb database also, but it's also a component. It also has this auth thing, which protects the set allowed function. So now the interesting part here is, what does it look like to run and install on this system? Well, it's actually not that complex. First, you hand the manager contract, like the contracts that have your access control state, you hand them off to an installer contract, right? That's after you grant permission to the installer contract. So in our system, that means you make the factory a root permission contract also. So the factory checks that precondition. Okay, this is fine. Then it's sets up a whitelist. This controller is the new controller, it's the whitelisted one. Then we give it root permissions. Remember, because it has to call the front end of the database. We set the whitelist, and we set the controller to the new controller, right? So this is not the old controller. And we have to refresh the environment on the front end because it depended on the old controller. So it needs to update the reference. The data store doesn't actually, even though we gave it root here, it doesn't actually need to refresh the environment, and we don't refresh the environment because of that. And then in our test, what this looks like is now, so this test is basically, the entire test contract has been updated to only test the whitelisted version. There's no more test coverage of like the old version. So that's why the setup function sets up the old system, but then it grants the factory root permissions, runs the updates script, quote unquote, and then it closes off those permissions. And then, it does the same thing, pulls these off the environment so that it can do all these tests on them, right? And then let me see if there's any more questions before I go on to the final concept here. Okay, guess not. So the last concept we have related to the DAPL toolchain is deploy scripting. So let me check out the right version again. I'm going to maybe be able to run this. I'm not sure. One sec. I did not actually test these against mainnet, so this may not, or like I didn't try deploying, or but I can show you what they look like. This is an example. Okay, so someone asked about gas cost concerns. When you need to split things across multiple transactions, but you still want to do it in a structured way, we have a domain-specific language called DAPL scripting, I guess, or deploy scripting is another term for it sometimes. And then this is interesting because this DSL is also potentially something that could be interpreted by a generic installer contract. So we're being careful to like specify the semantics to keep that open as a possibility. But it looks kind of like Solidity. It's not Solidity. You should not confuse them because this specifies a sequence of transactions, totally different semantics from something that gets compiled into EVM bytecode. But yeah, before, like in the test, we have in the EVM bytecode sequence of messages. So we make a new factory, then we call new demo system on the factory, and this is all happening atomically. Here, this is specifying a sequence of transactions that DAPL interprets. So first it creates this transaction, which creates a factory. Then it does a call on that factory, saves the address, and then pulls the token address off the manager, and then exports all three. And what export does, and here's where I don't have examples, so I will have to. Export does is it writes the address and types to your DAP file, right? You saw the empty environment object in the previous repo. Here it gets filled with Morden, which is the testnet, and then LiveNet. You have the object name, its type, and its address, and this is useful because then basically you can have. So let's say we ran this once. Then we think, okay, this is the system we want to publish, like publish this package, and then later we want to run an update Well, we have the context available here, so we can import those addresses and types from the DAP file, and it'll still, and you can use them in later update scripts that are off-chain. Okay, so I'm not going to try to run them. If you want, you can see the instructions for how to do it in the same. Let me actually write out the resources here. Let me get this and this are basically the two. DAPL is the tool I've been using. DAPS is the actually more advanced version of some of the concepts I went over in this demo. This is the demo repository that we just went through. And then let's see. Oh yeah, of course. Next is dev.us. Make sure it's online. This is where all of our other projects are, which has a ton of example projects built with this toolchain, with this methodology. And okay, I think I'm pretty much done with the time. Yeah, I'm about at the time limit anyway. So I guess I'm supposed to take questions for another 20 minutes or so. And I guess there's 19 people in chat, so just let me know if anyone, I'll stick around for a while and just answer questions in chat, and I can go through any other part of the code that you want me to again. How did I get into blockchain? I got into it because, let's see, I found Bitcoin early just randomly. I got into a project called BitShares, which was the first stablecoin attempt project, which actually still pretty much works. And it was around like right around the time that Ethereum was starting, actually, or like before Ethereum. And then I left that about a year, maybe a year and a half ago, and started working on Ethereum projects. Now I'm working, the main project I'm working on now is called Maker, which is at makerdao.com, and I have a development firm where we're actually handling a bunch of different projects at, and that's Nexus Dev that you can see right there. How can we learn all the key smart contract concepts? Let me get a link. I actually think that the Solidity, read the docs. I'm sorry, I'm typing and talking at the same time. Solidity, read. I'm trying to get the link for you. Here we go. This read the docs link, I'm going to paste it in the chat. Also here. That is like, if you can understand, well, yeah, so assuming that you understand the basic Ethereum model, which is that you deploy code, it gets an address, you can send transactions to it and send Ether to it. Assuming you get that, this is the next best thing, is it gives you just enough information about the EVM. I guess it teaches you all the relevant information about the EVM through the lens of actually using Solidity. And I think that there's also a Solidity features wiki doc that used to exist, which also I think is very useful. Yeah, here it is. Do you think ERC20 will become a solidified standard? Is there anything lacking? What features would perfect token standard have? ERC20 is a solidified standard. There is stuff lacking. It's just a standard. It's a sufficient standard for it to be a useful primitive, and since we can repackage things, then it's fine. Like, it's fine as a base layer. Is there anything lacking? What features would it have? I would say something like, I don't know exactly how to explain it, but one example is doing approve and call atomically. So you approve a contract and then you call one of its functions, and that function immediately pulls that token from you. A slightly more general version of that, I think, would require like a totally different standard. But it basically looks something like where the token asset flow follows the control flow rather than sort of being detached in the way that it is now. Yeah, I don't know. But yeah, it's definitely, I mean, if you have a token, you should make it ERC20. and then just extend, add functions. Are there any published design patterns on smart contracts? Yeah, kind of, but not really. So if you read the Solidity features or the Solidity tutorial, there's another. Yeah, let me link that one also. I guess I actually don't know where it is. They kind of are, but the thing is that they're not really like, they're too basic and not like battle hardened enough. Like I would have had this answer, the same answer like 3 months ago or 4 months ago. But the thing is that the patterns I thought were best then were totally different. So I would say, oh yeah, there is a good link actually. There's Eris Industries blog. Industries, smart contract systems. This is actually, I would say, where I sort of began thinking about these things as systems of contracts and how to, like what the correct separation of concerns is. But I think that they're a little bit outdated. Like he started writing them before Solidity even existed. So I'm not, you know, I think basically this is a more up-to-date version of the exact same blog. That is the only other design pattern thing I've read that's good. Can you provide an example of event for incoming transaction? What do you mean by that? Do you mean an event firing as a result of a transaction? Oh, one thing I can show you what a test would look like to test that a contract fires a transaction on a certain condition, if that's what you mean. It would look something like expect events exact on token, and then you define which events you want. So like event transfer, theory and value. This is like the event. So you say, I expect this event, and then you fire. Yeah, so this is from this to address 0 and 100, and then I expect. And then this would detect an event. Or this test should pass only if that event was fired. Does that answer your question? I can't tell if this yes is to that or to, yeah, okay, great. Okay, well, it looks like no more questions. I'll be here for like a minute or two more. I can also walk through, tell us about Nexus Dev. Okay, yeah, Nexus Dev. I think I can share the screen and then I can walk through basically all the different repos. Let me try this. Let's see if this works. That's not what I wanted. Let's see what you see. Do you see, dang it, it's only recursive, infinite recursion, huh? All right, let me try again. All right, I can just walk through everything we have, but we're a dev firm. We do a lot of R&D work. Well, yeah. As a firm, how we make money is consultation and building stuff for clients, but how we spend most of our time is actually building this tool chain because that's where the vast majority of the complexity is. So DAPL, this is the tool chain that I just showed you. DAPL script is in its own repository, the scripting language, the deploy script language I showed you. DAPL chain is an interesting project. It's basically we're making it so that you can fork the chain state locally and then apply fake transactions on top of it to simulate running an entire DAPL script, right? Because you can sort of right now you can sort of fake the result of one transaction. That's what the call API call does. But if you want to like apply a fake sequence look at the result and then decide if you want to apply it, this is the tool you want. And this is also like lets you like test deploy. So like if you're deploying against an existing system, you can fork and then make sure it linked together properly. And then you can also just test like test attacking like deployed systems too. Let's see, Feedbase is our feed app. Keeper is an off-chain incentivized daemon runner, which is basically any app. If you pay people to do anything, you should make a keeper task, and that'll happen. And then the idea is that keepers are people that want to run all the profitable incentives that they can, and so you have this. The result is you end up with the keeper swarm, which follows any like clearly outlined incentives that anyone presents to them. Let's see. The rest are basically a long tail of apps. There's maker stuff down here that you can look at as examples of how to use Dapple. So let me switch. I'll just leave it here actually. 1 second. All right. So any more questions? Yes. How is Dapple different from Truffle or Embark? I would say the main difference is the emphasis on the contract system layer and on keeping a very structured understanding like of what's going on in your system. Truffle, Embark is like, I think, not being maintained anymore, but I'm not sure about that. Truffle is, it's kind of converging actually. Dapple and Truffle are like are adopting similar concepts, but they are more, I would say like they're a web developer's approach to the issue. So like the contract system is much more static. It's assumed to be that it's relatively easy to set up, and you do it once at the start, and then they focus most of their energy on like the tool chain for like integrations and for the user interface. Although again, that's like me talking about what it was before when there was like a bigger contrast. Right now, I think they are adding scriptable deployment sequences too, for example. Oh, but that's actually maybe a good example of how they differ, is that their scriptable deploy sequence is written in JavaScript, and ours is written in a DSL, which has a type system that's a superset of the Solidity types. And so you can, there's trade-offs associated with each one. Maybe that's helpful to understand. What do you think about adoption? What are people going to be using? Geth, Mist, MetaMask, Light wallets. Geth is fine. I mean, everyone's using Geth, or Geth and Parity are going to be the two big clients. I like Parity a lot. It doesn't have a lot of adoption yet. So that's where you're going to be using if you're a dev. And then Mist, MetaMask, Light wallets. I don't think Mist is very good. I think MetaMask is awesome. I think the other Chrome extension wallet, I forget what it's called, My Ether wallet. Oh, it's right here on the screen actually. My Ether wallet. I think that one is awesome. Yeah, light wallets. Yeah, something like Mist is basically just a web app repackaged in Electron, as far as I can tell. So I think it's going to be outcompeted pretty quickly by just any other token wallet. Mist uses local node. Yeah, I currently use local node. That's just they're behind, I guess, right? Because there are light clients available. Comments on new bits. You can read our comments in, I think there's some stuff in MakerDAO subreddit, also on our Slack. I don't want to comment on it too much right now. We're not surprised. Let's put it that way. This is the exact anticipated failure mode that we've known for like a year and a half or whatever. Question is, let's say I have a contract waiting for funds sending to it from user. Is there a way I can build an event to watch and get transaction information out besides balance change? Yeah, so let me show you maybe. Yeah, so this transfer function fires this transfer event. This transfer event is defined somewhere. I don't know where. Oh, in ERC20. And the purpose of events is that they are like put into some sort of data structure, like a Bloom filter or something, where you can watch block headers and detect events in a light client. Please switch to your terminal. Oh yeah, sorry, good point. Blah, 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 blah. Here you are. This event is fired from here. So you can watch. You can basically, yeah, you can specify a filter on an Ethereum client which says if this address fires this event signature, do something like fire a callback, and that's only depends on the block header. So you can do that from the light client. Does that make sense? Great. All right, I'll wait one more. What if I have a list to address I want to filter? You can just, I guess, do them all. I guess it's linear with a number of different addresses. Yeah, I'm not sure the exact API, but it's in the Web3. It's part of the Ethereum RPC. Is the filter concept, and then like Web3.js has a wrapper where you can just pass in an array of whatever address, comma, event signature pairs. I don't know exactly how it works. I think you have to instantiate objects for each address and then call an event listener on each. For tokens with massive number of transactions, won't the gas fee force people to move away from frameworks with extra overhead? The thing is, there's also wrapper contracts, remember? So you can, you could do like you could have something whose transfer function is as efficient as the one you see right now, right? Or maybe even more efficient. I don't know exactly. I don't know if it's maximal. I don't know if it's like optimal. But the point is, then then the only question is what are cases where you can't just make a wrapper where it doesn't work directly, and that's an interesting thing. Like for example, like digits off the top of my head, right? They have to like demerge or something. So if you try to make a wrapper, you can make a wrapper contract which basically translated that into the price of the token, for example. So it would have to do some stuff, some logic when you're converting shares back and forth, or it would have to do similar logic of charging demurrage if it wanted to preserve the quantity. So that's one challenge. So in that sense, I think it does kind of, almost any system that's future-proof enough will, can reduce. The users will end up using the entry points which have only the true like gas cost, right? Because they're maximally efficient wrappers or whatever. Do you know of any REPL console like IRB for debugging? For debugging the EVM, no. Or for debugging Solidity, and debugging is really tough still. It's just the tooling is not great. So DAPL does have, so remember that virtual package DAPL/test? Well, there's also DAPL.debug, which I believe test imports. And I think I can open it, and then we can see which things are available. So basically what debug is any test contract during the run of the test, you'll get like the log output. So let me see if maybe we can do something. Do an example. That's really slow. I don't know why that's slow. And then let's see, is test, oh, it's because my computer is actually not charging. Okay. Sorry about that. You could add, yeah, test is a super class of debug. So if you only want the debug one and not the full test one, you can just do debug, and then you can log stuff. Like log named event balance, right, or something like that. And then if you want to see all the debug stuff you have available to you, that would be, let's see if it's here. Yeah, debug. This is a virtual package injected into the contract, and it's actually code generated a bunch of helpers. Actually, yeah, these are events. I don't know where the actual definitions are. I forgot. I think they might be on. I don't know. Anyway, you get a bunch of helper functions, and those are all documented again in the Tapper repo, which let me show you that URL. And of course, I'm doing the documentation on everything is like a for us, but that's where you would find, and let me put that in the chat also. Here's all the docs. You could look at test.md in there, and you can see like examples of logging. Okay. Okay, well, I think I have 2.5 more minutes, and then my conference ends. So I'll just wait around for any questions. You're very welcome. Thanks for listening. Okay, it looks like there's no more questions, so I'll just end it right now. Thanks, everyone.